And hi, my name is Lim Xiangjun, metric number 203104. Today, I'm going to conduct a home experiment, which is the acid-base titration. So, for this experiment, I use the acid which is vinegar, which is considered a strong acid, and sodium hydrogen carbonate, or we call it as baking soda, which will act as the weak base. So as the indicator, I will use the red cabbage. So before we start, let's see how to prepare the material for this experiment. Alright, so after the preparation of the solutions and indicator, I have poured about 20 ml of sodium hydrogen carbonate solutions into each cup presented here. So I have also labeled each cup with from 5 ml until the 35 ml. So I have 7 cups, so I have poured about 140 ml of sodium hydrogen carbonate. Moreover, I have also labeled each cup with the labeling showing from 5 ml to 35 ml because I have 7 cups right here. So 5 ml to 35 ml meaning that the amount of vinegar that I am going to add into. So now I have prepared the vinegar. Now I'm going to pour the pH indicator which I have prepared earlier. So let's see what is the changes. The pH indicator is initially purple in color. When we add into the vinegar solution, it turns pink, which showing that it is an acid. Next, we are going to determine the pH of sodium hydrogen carbonate solution. So the solution turns greenish and dark blue to showing it is an alkaline. So now let's restart the titration. We need to add the indicator, 50 ml of indicator into each cup, which contains a mixture of the sodium hydrogen carbonate with vinegar. So for strong acid, we use vinegar as our titrant and weak base baking soda as our analyte. So the observation is based on the color changes. So if you look at the indicator, the first sodium hydrogen carbonate that we use without any addition of vinegar, it gives a dark green color, which shows that it has 10 pH of 10. Same goes to the vinegar. It is between 1 or 2. Okay. Thus, the tabulation of data is done to record the changes in the pH. So first of all, without the addition of any vinegar, it gives 10 pH, and 5 ml of vinegar added give 8 pH, and continued until we get a constant pH, which is known as the over titration state. So the graph is plotted pH against the volume of the vinegar. So the graph is obtained from this origin where we show in 0 ml of vinegar until we get a constant value here. So our endpoint should be almost here at approximately pH equals to 7.5. It is impossible to get pH of 7 because these experiments involve strong acid with weak base, which will give the endpoint slightly above the pH of 7. The reaction equation given is like this, whereby our vinegar and the baking soda react, it will produce a salt with water and carbon dioxide. Carbon dioxide can be seen by air bubbles in the solution when we add vinegar into the sodium hydrogen carbonate. This salt will undergo anion hydrolysis to produce extra amount of hydroxide ion, making the endpoint is not 7. Instead, it is more than 7, maybe 7.5 until 8. Thus, in this experiment, there are some errors whereby the reaction between strong acid and weak base will not give pH of 7. Thus, the endpoint should be between 7 to 8, whereby I choose 7.5 as my endpoint. The use of natural indicator will not give accurate pH value. Yes, because we will see according to the color change. The theoretical pH of the baking soda is equals to 8, but experimental value is 10. Therefore, to improvise our experiment, we should conduct the experiment at least 3 times to reduce the error. Then we should use a proper and high sensitive indicator like pH meter to get accurate result. Thank you for watching this video. That's all from me. Bye bye.